Hey guys, welcome to the Trigonometry mini course. In this course, what we'll do is we will study the fundamentals of trigonometry. And many times the reason why you learn trig in school is so that it can prepare you for courses like calculus. And the thing with calculus is when you're first learning calculus, you don't need to know all the intricacies of trigonometry. You just need to know the basics. And so that's our goal with this course. The idea is to teach you the basics so that you have enough to start learning calculus on a comfortable footing. So let's get started. So what we'll do is we'll first look at similar triangles, because that's where the concept of trigonometry first originates from. This idea of looking at similar triangles. And in particular, they're going to be similar right triangles. So let's look at one similar right triangle and then another one, which we'll say is smaller, but again, similar. So it's also a right triangle, and because it's similar, it has all the same angles, like this. Now the side lengths of these will be totally different, but they do share one thing in common. Which is that the ratio of the sides between these angles in the triangle are identical. So let's be a little bit more specific. Let's say with respect to this angle, so this would be the opposite side. And then this would be the hypotenuse. And with respect to this angle theta, this would be the adjacent side. Just the naming convention that we'll use. So when we say that the ratios between corresponding sides are identical, what we mean is, regardless of which triangle you choose, the ratio between the opposite and the hypotenuse, they'll be the same, as long as they both have this angle theta. And we don't just have to look at opposite and hypotenuse. We could also, for example, look at the ratio between adjacent and hypotenuse. And also we can look at the ratio between adjacent or opposite and adjacent. So we have the ratios between the three sides. And regardless of what triangle you pick, as long as it's a right triangle with this angle theta, it will have these three ratios identical. So we'll call this sine of theta. So I should clarify, I don't mean that these three values will be equal to each other. I mean that all the triangles will have the same opposite over hypotenuse ratio. All of the triangles will have the same adjacent over hypotenuse ratio, and all of the triangles will have the same opposite over adjacent ratio. And because we're labeling them according to their angle, that's the one feature that they share, their angle, we are going to define these ratios based off of the angle. So we call this ratio opposite over hypotenuse sine of theta. And then cosine of theta, we'll call the ratio of adjacent over hypotenuse. And then tangent of theta, we'll call that opposite over adjacent. So these are the three trig ratios. And because they vary based on the angle, they're functions of an angle. Now the problem with these functions is that unlike a nice function, like for example, here's a nice function, f of x equals x squared. This is a nice function because if I give you some value, like say x equals 2, you'll be able to tell me, okay, f of x equals 4. You just square it. But that doesn't work out with these trigonometry functions, because if I just give you some angle theta, like let's say I have theta equals 25 degrees. Okay, now what is sine of theta, or sine of 25? Right? Well, if you just look at that, you wouldn't actually know off the top of your head. You wouldn't be able to compute that. Maybe you'd have to look at the triangle, 25, 90, and then 65-degree triangle. But just by knowing these degrees, we have no way of knowing the ratio between the sides, because we don't know anything about the side lengths just off the top of our heads. So that's a problem with these trig functions, which is that you don't necessarily know the values at a specific angle. So it is hard to compute sine of theta, and same thing goes for cosine of theta and tangent of theta at a specific theta. So how do you deal with these trig functions then? Well, there's two ways. There's two ways to get around that. One is not really a long-term strategy, but it's still useful, which is you can still compute them so compute trig functions at certain values. So we actually can compute these trig functions at some values, but they're only for some very nice values. Two is to look at so you look at their graphs and try to understand their behavior. So this might be things like, okay, what are the mins and maxes? What are the zeros of these trig functions? What does the graph itself look like? And later on when you study calculus, it'll be things like, what is the rate of change of these functions? So for now, let's look at number one. What are these specific values that I can compute trig functions? What are the convenient values? Well, there's two cases. And it all involves having a triangle that you know the side lengths of, a right triangle, that is. And not only that, but we also need to know the angles that correspond to those side lengths. So first, let's start with the 45, 45, 90 right triangle. So the way that this triangle comes into being is you start with a square and you cut your square in half like this. So once you've cut it in half, you have 45 degrees here and 45 degrees here. And let's just say the side length of the square is 1. That means the other side of this square is also 1. And now the side length of the hypotenuse, that's square root of 2. So now if I want to compute, for example, cosine of 45, I can look at my formula for cosine that I've defined to be adjacent over hypotenuse. And now the adjacent side is 1, and the hypotenuse is square root of 2. So I get square root of 2, 1 over square root of 2. Now the other type of triangle is known as the 30, 60, 90 triangle. 30, 60, 90. Now the way that this triangle comes into being is you first start with an equilateral triangle. So with an equilateral triangle, all the sides have length 60. Or all the angles have measure 60 degrees. And all the sides are equal. Now what I'm going to do is I'm going to cut this triangle in half. And because I cut it in half, say it had side length 1 originally. Well, because I cut it in half, now it's 1/2 and 1. So what I'm left with is a right triangle with side length 1/2 and 1. And then the degrees for this would be 30 and 60. And so that's why it's called a 30, 60, 90 triangle. And to find the length of this missing side, we'll again use Pythagorean theorem. So this would be square root of 1 squared minus 1 over 2 squared, which turns out to be square root of 3 over 2. So now you can answer questions about this. For example, what is sine of 30 degrees? Well, if we look at our triangle, 30 degrees is over here. And now opposite over hypotenuse, that's 1/2 over 1, which equals 1/2. I can also look at cosine of 60 degrees, for example, and that would be 1/2 over 1. Now, I could also, for example, look at tangent, because we haven't done tangent as an example yet. So let's also do tangent of 60. So tangent, remember, is opposite over hypotenuse. And this would be square root of 3 over 2 over 1, which is just square root of 3 over 2. Okay, so there you have it. These are some example calculations. And typically what happens is when you first learn this, your teacher in class, they'll give you an entire circle or entire set of angles, and you have to compute all the sines and cosines and tangents of them. And that's a really tedious exercise. But it's a good exercise because eventually you're not going to be computing these angles like we do over here. Eventually you're just going to be able to see the angles and intuit, oh, okay, it's going to be 1/2 or square root of 3 over 2. And it's kind of like your multiplication tables in that sense, where after a while you just have the values internalized. So for now, I'll just give you some sample calculations for practice. And you can also find these exercises in the handout. But here's what I would recommend you practice calculating. And essentially, any angle that belongs to this triangle or this triangle, you just take that angle and then you try to compute either sine, cosine, or tangent of it. So that's essentially what I'll be writing down. So notice we have looked at one of these exercises before. We have looked at tangent of 60 already, but it's just there for you to try again. Okay, so that's all for this section. In the next section, we'll see an example of a way to measure angles, which is actually more natural than degrees. So I'll see you there.